Section 2.1, use inductive reasoning. So our goal is to describe patterns and use inductive reasoning. Describe the pattern in the numbers 1,500, 250, 125. You may say that the pattern is 2 divided by 2. Another way of saying this, if I looked at it from a multiplication point of view, would be to multiply by 1/2. Multiplying by 1/2 and dividing by 2 are the same thing. So the next question is, what are the next three numbers of the pattern? So we're simply going to take our 125 and multiply by 1/2, and we get 62.5, 31.25, and 15.625. So we're just following the pattern. The next term we have is conjecture. A conjecture is an unproven statement and it's based on observations. And when we're talking about conjectures, we're talking about something that is called inductive reasoning. And inductive reasoning is when you find a pattern and then write a conjecture for the general rule. So we have an example here of using inductive reasoning. It says, given the pattern of triangles below, make a conjecture about the number of segments in a similar diagram with 5 triangles. So if we look at the first one, we have one triangle, 3 sides. Here we have 2 triangles, and 1, 2, 3, 4, 5 sides. Here we have 3 triangles, 1, 2, 3, 4, 5, 6, 7 sides. And you may see for each additional triangle, we add 2 sides. So 4 triangles would be 9 sides, and then 5 triangles would be 11 sides. So our conjecture would be, for the diagram with 5 triangles, we would expect there to be 11 segments or 11 sides. Numbers such as 3, 11, 15, and 29 are odd numbers. Make and test a conjecture about the product of any 2 odd numbers. What do we know about odd numbers? Well, first of all, what does product mean? Multiplication. So do we know when we multiply 2 odd numbers together? It's odd. So our conjecture is the product of odds, or product of odd numbers, is odd. That is our conjecture. To test it, we're going to try a few. So 3 times 11 equals 33. 33 is an odd number, so that one works. 11 times 15, 165. Also an odd number, that one works. 3 times 29, 57. Also an odd number. We'll try one more for good measure. 15 times 29 is 435. Also an odd number. Our conjecture seems to work. What happens when it doesn't work? Well, we must provide a counterexample. So a counterexample shows that a conjecture is false. An example, all prime numbers are odd. Your counterexample, 2. 2 is a prime number and it's not odd, so right there would be a counterexample. Another way of thinking of this, one counterexample equals a false conjecture. All it takes is one. Find a counterexample to disprove the conjecture supplementary angles are always adjacent. So we know that supplementary means sum to 180, and adjacent means they share a side. Is there a way to draw a pair of angles that sum to 180 that don't share a side? And the answer is yes. So I have an angle here that's 120 degrees. I have this one here that's 60 degrees. Are they supplementary? We'll check. 120 plus 60 equals 180. They are in fact supplementary. Are they adjacent? No. Therefore, we have a counterexample. It's that simple.